Good morning, all. Today I am going to start my third lecture of quantum number. Before we start the session, now we have to recap the first lecture and second lecture of quantum number. First of all, come to the live session and join. Okay, students, suppose this is your nucleus. Inside the nucleus, proton and neutrons are present. Okay, suppose this is your first cell. Which cell? First cell. And we know that for first cell, the value of principal quantum number is 1. The value of n is equal to 1. Next. Suppose this is your second cell. And we know that for second cell, the value of n is equal to 2. And after second cell, third cell come. Suppose this is your third cell, and for third cell the value of n is equal to 3. And also students, we know that in first cell one subcell is present, and this subcell is your S subcell, and the value of L for S subcell is equal to 0. And also we know that for second cell there are two subcell is present, one is S subcell and another one is P subcell, and the value of L for S subcell is equal to 0 and the value of L is equal to 0 for P subcell. And after second cell, third cell will come, and also we know that for third cell the value of n is equal to 3. And since the value of n is 3 for third cell, that's why there are 3 subcells are present inside the third cell, and the subcell are S subcell, P subcell, and this is your D subcell. Now draw the structure. Students, this is your S subcell. This is your S subcell, and in second cell there are two subcell is present. One is S, another one is P, and in third cell there are three subcell are present. One is S, another one is P, and third one is D. Also we know that students, for S subcell, what I am saying, for S subcell the value of L is equal to 0, and for P subcell the value of L is equal to 1, and for A subcell the value of L is equal to 0, and P subcell the value of L is equal to 1. For D subcell the value of L is equal to 2. Students, also we know that S subcell have 1 orbital, P subcell have 3 orbitals, and the orbitals are px, py, pz. And I am saying that if lobes are present along the x-axis, then we say this is your px orbital. Suppose lobes are present along the y-axis, we say this is your py orbitals. For example, suppose this is your x-axis, this is your y-axis, and this is your z-axis. And we know that each axis are perpendicular to each other. Suppose lobes are present along the x-axis, we say this is your px orbital. Suppose this is your y-axis, if lobes are present along the y-axis, this is your py orbital. Suppose lobes are present along the z-axis, we say this is your pz orbitals, and px, py, pz orbitals are present in P subcell. And also we know that students, who can say the formula, the orbitals present in a subcell, what is the formula? And we know that the formula is 2l plus 1. Suppose we put L is equal to 2 because the value of L is 2 for D subcell. If we put this value, the result should comes out 5. That means D subshell have 5 orbitals, and the 5 orbitals are dxy, dyz, dzx, and dx square minus y square and dz square. Also, we know that d orbitals are classified into two parts. One is non-axial d orbitals, another one is axial d orbitals. Non-axial orbitals are dxy, dyz, dzx, and axial orbital is dx square minus y square dz square. Okay, students, and also we know that we use sign box. We use sign box for orbitals. Since one orbital is present in a subshell, since one orbital is present in a subshell, that's why we draw one box. In second cell, first is present s orbitals and p subshell have 3 orbitals. That why we draw 3 box. This is your px, py and pz. Similarly, we draw one box for s, 3 box for p and 5 box for d, because there are 5 orbitals are present inside the d subshell. Okay, now this is the recap. This is the recap of first lecture and second lecture. And we know that suppose we go towards right, that means distance increases. That means distance increases from the nucleus. Okay, now start. Students, we discuss what do you mean by degenerate orbital. What do we mean that? What do we mean that degenerate orbitals? Degenerate orbitals. What does it mean that? Students, we know that the orbitals which have same energy. What I say? The orbitals which have same energy, and these orbitals are known as degenerate orbitals. Students also know that this degenerate word is directly associated with energy term. Which term? Energy term. Because suppose there are 5 orbitals in d subshell. For d subshell, there are 5 orbitals are present: dxy, dyz, dzx, dx square minus y square and dz square. And for p subshell, there are 3 orbitals. This is your px, py and pz. Since these have same energy, that's why this is known as degenerate orbitals. What we say, students? Degenerate orbitals. And also we know that this is called as degenerate orbitals. What we say? Degenerate orbitals. Okay, students. Now come to the next point. Students, I want to give you complete information. What I say? I want to give you complete information, cell, subshell and orbitals. Before we start this term, I want to give you another concept. This concept or this point is, please focus on board, and the number of, what I say, the number of orbitals are present, within the subshell. What I write, students? Within the subshell is given by the formula is 2L plus 1. What I say? 2L plus 1. And for each value of m, what I say, students? For each value of m, there exists an orbitals. What say, students? Say there exists an orbitals, and the value of m lies between minus L2 plus L. What I say, students? The value of m the value of M lies between a range between minus L to plus L. That means the value of M, what I say students, the value of M lies between, the value of M lies between minus L to plus L. What I say students, please focus this point, the value of L lies between minus L to plus L. Now I want to give you the complete information of cell, subshell and orbitals, and after completing this concept, I want to give you some formula. This formula is comes from this concept. Okay, now starts. Suppose students, this is your cell. What I say, this is your cell, and also we know that cell principal quantum number, and we know that also azimuthal quantum number, and azimuthal quantum number gives idea about subshell. What I say students, the azimuthal quantum number gives idea about subshell. After azimuthal quantum number, then third quantum number is your magnetic quantum number, and the magnetic quantum number gives idea about your orbitals. Students, who can say the definition of orbitals and the definition of nodes? Please write in the comment box, what do you mean by orbitals? Students, we know that orbitals, the region in 3D space, the region in 3D space, or the electron lies around the nucleus in 3D space is known as orbitals. That means, suppose students, I write, who can say, tells with me, suppose I write n is equal to 1. What I write students? N is equal to 1. N is equal to 1 means your first cell or K cell. And also we know that the value of L, what I say, the value of L lies between 0 to, what I say, 0 to n minus 1. Students, remember that I say for each value of L, there exists a subshell, and the value of L lies between 0 to n minus 1. What I say? 0 to n minus 1. If we put this n is equal to 1, the result should comes out L is equal to 0. Since the value comes out one value, and this value is your L is equal to 0, that's why one subshell is present. This is your which subshell? A subshell. Okay, and also we know that the number of orbitals, what I say students, the number of orbitals present in a subshell, the formula is 2L plus 1. If I put L is equal to 0 in this formula, the result should comes out 1. That means A subshell have, what I say students, A subshell have 1 orbitals. And students, we know that for an orbital we use box. Okay, now students, let's say, suppose this is your n is equal to 1 and this is your n is equal to 2. If I write n is equal to 2, students, if I write n is equal to 2, n is equal to 2 means this is your second cell, and in your second cell there are two subcells present. One is S subshell and another one is P subshell. Because if we put value n, the 2, that means 0 to 2 minus 1, this is your 0, L is equal to 0 and L is equal to 1. What I say? L is equal to 0 and L is equal to 1. And we know that for A subshell, the value of L is equal to 0. For P subshell, the value of L is equal to 1. And also students, we know that, what I say? We know that A subshell have one orbital. A subshell have one orbital. Since A subshell have one orbital, that's why we represent only one box. How many box? One box. Because students, next, for P subshell, there are 3 orbitals. This is your Px, Py, Pz. What I write students? Px, Py, Pz, Px, Py, and this is your Pz. Okay. Next start, come to the third cell, and for third cell we know that the value of n is equal to 3. The value of n is equal to 3, and we know that in third cell there are three orbitals are present, or three subcell are present. This is your S subcell. Suppose L is equal to 0, L is equal to 1, L is equal to 2. For third cell, the value of L comes out 3. One is 0, one is 1, and another one is 2. That means when I say L is equal to 0, that means this is your S, this is your P, and this is your D. What I say, students? This is your S, this is your P, and this is your D. And also, students, we know that for S subcell have 1 orbitals. For P subcell, this is your 3 orbitals. For D subcell, this is your 5 orbitals. This is your 5 orbitals. Students, we know that the value of M, what I say, the value of M lies between minus L2 plus L. What I say, students? Minus L2 plus L. That means the value is, suppose this is your 0, M is equal to 0, M is equal to 0, and this is your M minus 1, 0, plus 1. There are 3 M values. This is your M is equal to 0, this is your M is equal to minus 1, 0, plus 1. This is your minus 2, because minus L2 plus L, the value of M lies between minus L2 plus L. And for D subcell, what I say, students? For D subcell, the value of L is equal to 2. That means the value lies between minus L2 plus L. That means for D subcell, the value of M lies between minus 2 to plus 2. That means minus 2, minus 1, 0, plus 1, and this is your plus 2. Since M have 5 values, what I say, students? Since M have 5 values for D subcell, that's why 5 orbitals are present inside the D subcell. Now come to the next slide for fourth cell. Last is for fourth cell. What I say, students? For fourth cell, there are L is equal to 0, L is equal to 1, L is equal to 2, and L is equal to 3. Since the value comes out for L is equal to 0, L is equal to 1, and L is equal to 2, and L is equal to 3. That means there are 4 subcell are present. There are 4 subcell are present in fourth cell, and L is equal to 0, S, L is equal to 1, P, L is equal to 2 for D, and L is equal to 3 for F subcell. Okay. And also, students, we know that S subcell have 1 orbital, P subcell have 3 orbitals, D subcell have 5 orbitals, F subcell have 1, 2, 3, 4, 5, 6, 7. Okay, 7 orbitals. That means this is your M is equal to 0. M lies between minus 1, 0, plus 1. Minus 1, 0, plus 1. Here M is equal to minus 2, minus 1, 0, plus 1, and this is your plus 2. That means, students, here for F cell minus 3, minus 2, minus 1, 0, plus 1, plus 2, and for 3 plus 3. Okay, students, I want to give you the most interesting point or most interesting concept. Students, please focus on board. Please, here the value of n is equal to 1. What I say, students? The value of n is equal to 1, and the orbital is present in first cell is equal to the subcell is present in first cell. This is your S subcell. Students, here the value of n is equal to 2. What I say? The value of n is equal to 2. That means there are two subcells are present. What I say? Two subcells are present inside the second cell. Students, for third cell, we know that n is equal to 3. That means there are three subcell. What I say, students? There are three subcell are present: S, P, and your D. Okay. Now come to the next slide, students. Students, focus on board. The value of n is equal to here 4. Since the value of n is equal to 4, that's why there are four subcells. There are four subcells are present inside the fourth cell, and the subcells are S, P, D, and F. S, P, D, and F. That means we write the most important point, the number of subcell. What I write? The number of subcell are present in a, the subcell are present, the number of subcell are present within the cell, within the cell is equal to, students, what I write? Is equal to n, is equal to n. Okay. And also we know that the maximum number of electron present, the maximum number of electrons, what I say, students? The maximum number of electrons present in a cell is given by the formula 2n square. What I, students, write? 2n square. 2n square. Students, come to this slide. Students, there are one orbital is present for first cell. There are four orbitals are present. There are four orbitals are present in second cell. There are 9 orbitals are present inside the third cell, and there are 16 orbitals are present inside the fourth cell. That means the number of orbitals, what I say, students? The number of orbitals present in a cell. The formula is the most important point, and the most important point is the number of orbitals. What I write, students? The number of orbitals present. The number of orbitals present inside the cell. Inside the cell is your students, what? N square. What I write? N square. The maximum number of electron present, this is your 2n square, and the number of orbitals present in n square, and the number of subcells present in your cell, this is your, the value is equal to 1. Okay, students, this is your complete information about magnetic quantum number. And after completing the magnetic quantum number, now we start last quantum number, and last quantum number is your, students, tell me with me, the last quantum number is your spin quantum number. What I say, students? Spin quantum number. Students, like principal quantum number is represented by n, azimuthal quantum number is represented by L, and magnetic quantum number is represented by M. Similarly, the spin quantum number is represented by small s. What is right? It is represented by, that means spin quantum number is represented by small s. Students, spin quantum number, what does it tells about or what does it suggest that? Spin quantum number gives idea about the spin of an electron. What I say, students? Spin quantum number gives idea about the spin of an electron. That means we write spin quantum number gives idea about. That means we write it gives idea about spin of an electron. What I write? Spin of an electrons. Students, when I say the spin of an electron, what does it mean that? That means electrons revolves in their own axis. What I say? Electron revolves their own axis. Okay? And there are two orientations. How many orientation? Two orientation. One is your clockwise and another one is anti-clockwise. That means there are two types of orientation or two types of orientation of an electron. That means electrons have orient clockwise direction and electrons revolves in their own axis in anti-clockwise direction. Students, remember that for clockwise orientation, we use the value of S is equal to plus half. What I say, students? The value of S is equal to plus half, and for anti-clockwise orientation, what I say, students? For anti-clockwise, we use S is equal to minus half. What I, students? S is equal to minus half. Simply it represents, students. Also, we know that we use this symbol for an electrons. What I say, students? This symbol used for an electrons. If one electron is present, then we use this sign and also use for this sign. Students, there are two spin of an electron. One is up spin and another one is down spin. What I say, students? One is up spin and another one is down spin. For up spin, we use this sign. That means this is your off sign and the arrow towards above. Okay? This is your play. This is your, students, your down spin. What I, students? This is your down, students, down spin. That means we use this sign. What I say, students? We use these signs for your down spin. What I, students? For your down spin. Students, let's start the very important concept. Student, before I start this concept, I want to say that one concept is node. One concept is node, and node means where the probability finding of an electron is 0. We take completely one class for node and we start how we write electronic configuration. What I say, students? How to write electronic configuration. How to write electronic configuration for an atom or an ions. What I, students, I write? How to write? This is the most important point for your NEET, JEE, class 11 and class 12 exam. How to write electronic configuration for an atom or ions. Students, before we understand this concept, how to write electronic configuration for an atom or ions, we have to, or this concept follows 3 rules. How many rules? 3 rules. One is Aufbau principle, another one is Bond's rule for maximum multiplicity, and third one is Pauli's exclusion principle. What I say, students? Pauli's exclusion principle. Students, tell with me, how many rules that follows how to write. This is your electronic configuration. What I say, students, that electronic configuration, that means we have to obey 3 rules. How many rules? 3 rules. This is your Aufbau principle. Second one is Hund's rule for maximum multiplicity, and third one is your Pauli's exclusion principle. That means we have to obey 3 rules to write electronic configuration for an atom or an ion. First is Aufbau principle. First one is your Aufbau principle. Second one is Hund's rule for maximum multiplicity. Students, what I said that Hund's rule for maximum multiplicity. Okay, students, what I say? Hund's rule for maximum multiplicity. Hund's rule for maximum multiplicity. This is your Aufbau principle. This is your Hund's rule for maximum multiplicity. And third one is your Pauli exclusion principle. What I say, students, that Pauli's exclusion principle. Pauli's exclusion principle. That means, students, we obey 3 rules for writing an electronic configuration for an atom or an ion. Students, next we understand what is your Aufbau principle and what is your Hund's rule for maximum multiplicity and what is your Pauli's exclusion principle and how they applicable in when I write electronic configuration for an atom or an ions. Okay, students, let's start Aufbau principle. Let's start Aufbau principle. Students, what I write? Aufbau principle. Students, before start this concept, I am asking you one question. If you know, then write our comment box. Suppose, students, when I write 1s, what I say? 1s. What I say, students? 1s. Suppose I write 2s. Suppose I write 3s. What I, students? Suppose I write 1s. Suppose I write 2s, and suppose we write 3s. That means, what does it mean that? Students, we know that this is your n is equal to 1, this is your n is equal to 2, and this is your n is equal to 3. What are, students? N is equal to 3. Students, n is equal to 3. Students, that means S subshell is present in your first cell. 2s means S subshell present in your second cell. 3s means S subshell present in your third cell. Students, then question is, what is the difference between them or among them? What 1s, when I say 1s, when I say 2s, and when I say 3s. That means, students, and also we know that, students, also we know that the shape of S subshell is spherical. The shape of S subshell is spherical. That means the shape of S subshell is your spherical, and we use positive sign because positive sign indicates nucleus present inside an atom. Positive sign indicates what? Nucleus is present inside an atom. That means, suppose, students, that means S subshell belongs to first cell, S subshell belongs to second cell, S subshell belongs to third cell. Complete the information that this is your nucleus, this is your first cell. That means I write n is equal to 1. For second cell, I write n is equal to 2. And for third cell, I write n is equal to 3. When I say 1s orbital. Students, when I say 1s orbital, that means this is your 1s and this is your 2s and finally this is your 3s. That means suppose this is your 1s, this is your 1s, this is your 2s. Students, know that this is your 1s, this is your 2s, this is your 3s. Students, I write this is your 3s. That means when I say 1s, 2s, 3s, that means the 1s, 2s, 3s subshell are same in three cases. S, but when I write 1, when I write 2, and when I write 3, that means int indicates the size of a subshell. What I say, students? When I say 1, 2, 3, 1, 2, 3 represents the cell number, and also, students, we know that the first point of principal quantum number gives idea about size and energy of a cell. Students, what I say? The size and energy of a cell. That means when students, remember that as the value of n increases, energy and size also increases. What I say, students? Energy and size also increases. That means this is your first, this is your second, this is your third cell. When the value of n increases, size of the subshell also increases. Let's come to the p subshell. Students, let's come to the p subshell. Let's come to the p subshell. Students, what I say? Let's come to the p subshell. Students, suppose we know that in second cell p subshell is present because there is no p subshell present inside the first cell. Suppose this is your 2p. What I say, students? This is your 2p. That means suppose this is your 2p, this is your 3p, this is your 4p. What I say, students? This is your 2p, this is your 3p, and this is your 4p. That means, students, we know that p subshell present in which cell? Second cell. P subshell present in third cell, and p subshell present in fourth subshell. When I say here n is equal to 2, what I say, students? Tells with me, n is equal to 2. Here n is equal to 3. Here n is equal to 4. Students, my question is how to link one concept in another concept, or how we apply one concept in another concept, because this is your concept of principal quantum number. Students, what I say? This is your concept of principal quantum number. I use this concept in above principle. Okay, students, that means this is your 2p and this is your 3p, and also, students, our favorite color for our Rajesh sir, this is your 4p. That means this is your 2p, this is your 3p, and this is your 4p. That means when I say 2, when I say 3, when I say 4, that means as the value of n increases, size also increases. As the value of n increases, that means size also increases. That means, students, see that this is your size of 2p. When I say when the value of n increases 2 to 3, size also increases. When the value increases 3 to 4, that means size also increases. That means n, and how n can apply on Aufbau principle. Okay, students, this is your complete information about 2p. Students, when I write 3d, when I write 4d, when I write 5d, that means the size increases. What does I say that? The size increases 3d, then 4d, then 5d. What I say, students? First, the list size is 3d, then size increases when we move 3D to 4D, then size increases when we move 4D to 5D. Students, please focus on concept. You have to understand one concept properly, because when your concept is strong, then you are applicable to crack NEET and JEE entrance. To crack NEET and JEE entrance, that means you have to always focus on your concept. What I say, students, please focus on the concept. Okay, students, above principle based on the term energy. What I students say that the above principle present on or described on the basis of energy. That means above principle, that means above principle completely based on the concept energy. Silent, the concept of energy. That means, students, we know that everybody wants to stay in stable form. Students, what I say? Everybody wants to stay stable form. That means in chemistry, always we compare who is the less stable and who is the more stable. Since everybody wants to stay in stable, that means, students, I give you a relation. The relationship is between or in between energy versus stability. What I say, students? Energy versus stability. That means, students, this is your inverse relation. What I say, students? This is your inverse relation. That means when energy increases, students, tells with me, when energy increases, stability decreases. When energy decreases, stability increases, and everybody wants to stay in stable form. That means when energy increases, stability decreases, and when energy decreases, stability increases. That means, suppose, students, suppose this is your electron. Focus in. This is your electron. Suppose I want to give you one place is your A place. I want to give you another place. This is your B place. Okay. Place. Suppose A have lower energy. What I say, students? A have lower energy as in compared to B. In compared to A, B have high energy. B have high energy. Suppose one electron comes. My question is, this electron prefers which place, either A or either B? Students, my question is, suppose electron comes and they have two places to stay here. One is A, another one is B. And we know that A have lower energy as compared to B, and B have higher energy as compared to A. That means, students, the most important point, everybody or everyone in our chemistry wants to stay in stable form, or wants to attain or wants to gain stability. That means here we know that energy is inversely proportional to stability. That means who have higher energy, they have lower stability. Who have higher energy, they have lower energy, they have higher stability. That means when electron comes, they choose lower energy place. They choose what? Or he choose lower energy place, because lower energy, when the energy is lower, stability is more. When energy is higher, stability is lower, and everybody wants to stay in stable form. That means electron prefers lower energy state rather than higher energy state, because when electron present in lower energy, they feel or he feel more stable as compared to when electron present in your higher energy state or higher energy place, and this place is your B place. This place is your B place. That means suppose I write 1s, suppose I write 2s, suppose I write 2p, suppose I write 3s, then 3p, then 3d. What I say, students? 1s, 2s, 2p, 3s, 3p, and 3d. Suppose, students, you know that finally electron stay in your cell, or we say that in your subshell, or we say that in your orbitals. Finally, electrons stay in cell or in subshell or in orbitals. That means we have to calculate, or we have to know that before entry the electron subshell, because suppose we have 1s, suppose we have 2s, 2p, 3s, 3p, and 3d. Suppose one electron is come. Okay, what I say? One electron is come. They have this type of possible place he can stay. What I say, students? There are different kind of place the electron can stay. That means electron choose who have lower energy, then he select the lower energy place, and finally he stays here, because those who have lower energy, he have more stability. That means we have to calculate 1s, 2s, 2p, 3s, 3p, and 3d who have lower energy. What I say, students? Who have lower energy, and above gives idea about how to calculate. Students, tell me with me how to calculate who have lower energy and who have higher energy. Students, again I repeat that above gives idea about energy concept. That means when electron comes, they have 5 place, and he have 5 place, then he has to choose one place, and which place is more preferable for an electron. That means we have to use energy concept, and then who have lower energy, electron finally goes to lower energy cell. That means, suppose students, we use n plus L value of, this is the most interesting concept. The concept is n plus L value. That means n plus value is directly proportional to energy. What I say, students? N plus L value is directly proportional to energy. That means when we want to calculate energy, who have lower energy and who have higher energy, then we have to use this formula. What I say, students? We use